Hey guys, so in this video we're going to go through a couple examples of using chain rule. So we're working on page 235 out of the book and looking at example 11, which has three different parts to it. So I'm just going to walk us through three different parts. So quick intro, like refresh here. Chain rule is used anytime you have a composition of two or more functions. I think we're going to focus just on having two composed functions, but it does work for more compositions than that. And the main important thing here is to find your inner function and your outer function. So understanding how those two things are related, but separate pieces is going to be the key to using chain rule. So let's look at this first example together. I want you to pause and think about, like, what is the inner function here? I do think that finding that inner function is the easier one, and then seeing the structure around that inner function. So by now, hopefully you're thinking, well, the inner function has got to be the thing inside those parentheses. And that's common that it'll be that way. It's whatever's kind of inside parentheses, or maybe inside of a square root, or inside of something, right? So whatever the inner function is, I want you to call u. And then the outer function is f of u. So what's the outer structure acting on u? It's a cube function, u cubed. So I can see, and just like check this for yourself, that if you take this and plug it in for u over here, you should get that original function composition back. And just kind of quickly checking in my mind, if I take x squared minus 4x and stick it in here, then I get x squared minus 4x cubed, and that is what I had originally. All right, next step in this process is to find the derivative of your inner and outer functions. So this is du dx is equal to 2x minus 4, and that's just power rule, so using those exponents. F prime of u, again, power rule is 3u. Okay, so if I want to find our derivative of y, which you can call dy dx, or if you'd like, you can call this y prime, but I think for now dy dx is nice because you can put these steps together. So it's going to be f prime of u times du dx. So we're looking at a derivative with respect to u times the derivative of u with respect to x. And this looks just like 3u times this guy, 2x minus 4. And when I start to back substitute, remember that if your answer starts, or if your problem starts in x, your answer has to end with x's, not u's, no combination here. U, again, is just this guy, so let's be careful and mindful as we back substitute. It's x squared minus 4x times 2x minus 4. And we didn't look super closely at this in class, but I do want to pause for a second and just have you sort of appreciate what this looks like. If I look back at this original, oh, sorry, I missed my square. Whew, it's probably bothering a ton of you for a long time. Sorry about that. Okay, so if you're looking at kind of that original problem back there, when you start on the outside of the problem, so if you're taking your x squared minus 4x cubed, start with like that outermost layer and take the derivative of just that thing. Notice how the inside doesn't change. Notice how u here doesn't change. That inner function initially stays the same. So if you want to go layer by layer, start with the outside, kind of like an onion, like peeling back layers of an onion. That I'm taking the derivative of the outermost first. So the outermost is a cube. So I bring down the 3 and drop the power by 1. That's just power rule. The inside does not change at this step. So I've taken the derivative of the outer and then multiply by the derivative of the inner, which is just 2x minus 4. And now you can see that this answer we just got here is the same as this answer over here. So I'm just trying to illuminate these things that are changing, what is happening, and what is actually staying the same. So at that first step, the 3u squared, you can kind of see and appreciate that that inner piece, whatever u is, doesn't actually change on the first step, the f prime of u, 3u squared. It stays 3 of whatever u was, and then you multiply by the derivative of that inner piece. So that's kind of a trick that I use in my head to observe structure and layers, and it helps my derivatives to go much faster. Okay, so we're going to go through another example problem, and I'll probably take you through this same walkthrough so you can start seeing the layers unravel even more quickly. All right, so in this next problem, we have a square root. But I think we've kind of learned and gotten comfortable with the idea from power rule that square roots are really just exponents. And if I can transport them into exponent land first, then my power rule takes over and it becomes a much easier process. So before starting in on the inner outer function idea, I'm going to change my square root into a exponent first. Okay, square roots are 1/2 power. So now I start to observe like chain rule. There is an outer function and an inner function. And I almost like to think of the outer structure as like something happening to the inner structure. It's like if I were to plug in a number here, I would first square it, multiply by 5, subtract 2, and then take the square root of that thing. So it's almost like the outer function is acting upon the inner function. It's like an operation. That's how I can kind of tell when I have function compositions and when I need to use chain rule. So inner function is what we call u, and it's going to be 5x squared minus 2. That's my innermost function there. And then f of u is that outer structure like the house. So whatever's happening to my 5x squared minus 2 is the outer function. And I can see it's going to be like a u to the 1/2 power. And now let's find out what du dx is. Using power rule, bring down the 2 and I get 10x. This is a constant, so it becomes 0, it's gone. F prime of u, pull down the 1/2 power and subtract by 1, and I get negative 1/2. And now let's put these pieces together. So if I want to find y prime, which is just dy dx, I've got to do the derivative of the outer function times the derivative of the inner function, du dx. And again, in our last example, I pointed out how that inner function on the first step of the derivative right here does not change. So it's 1/2 u to the negative 1/2 power times the derivative of the inner, which is 10x. And when I back substitute, it's going to look like 1/2 times u is 5x squared minus 2. And it's to the negative 1/2 power. And then times 10x. Now in class I had a question come up about like, do you want us to multiply this out or simplify this? How do you want to see our answers? At this step, we really need to simplify this more. And the reason is because I've got negative exponents with rational exponents, fractions, the 1/2. I've got 10x over here. For my reader to look at this and interpret what's going on, it's very awkward. And honestly, it might feel very awkward for you and you're not even sure what you're looking at. So let's unravel this step by step. To simplify, I might keep my 1/2 out in front. This negative power tells me it drops down to the bottom. The 1/2 is a square root. So this becomes 1 over square root of 5x squared minus 2. And then multiply by the 10x. Okay, this is already looking a lot better. So check it out. 10x drops on top. I've got the 2 with the root here. And then I should absolutely be simplifying those 2's. And my final answer looks like 5x all over square root of 5x squared minus 2. Okay, so there's our answer here. Now, in the last video, I kind of, or not last video, but in the last problem, I was talking in terms of like, you can kind of do this in your head if you observe outer structure and inner structure. and take the derivative starting from the outermost and working down into whatever the function is at the innermost level. So I'm going to demonstrate how to do that here with this problem, but I'm going to need a little space, so I need to cut the video for a second. Okay, so we already know from the work we just did that this is the derivative, and now I just want to show you almost how to see it without having to write out every single step. So again, focus on that outer structure, take derivatives one layer at a time on your way in. Okay, so if I want to know what y prime is, I'm going to start with my outer structure first and take the derivative of just that piece. So on the outer structure of this, I can see it's a 1/2 power. That's what the function is, really. So if I pull that 1/2 power down in front, the derivative is literally this. And notice how I'm leaving the parentheses blank right now? It's because I know that that u portion doesn't actually change on that first step. Just the outer piece, not the inner piece. The inner piece is like a crystalline structure that is never touched until I actually take the derivative of it. So at this next step, you know, the first step was outer derivative. Next step, you multiply by the inner derivative. And that inner derivative is this guy. So 10x. Now I'm gonna like stick the u portion back in. I just really wanted to make a point that you don't even need to pay attention to that inner function yet because you're not doing anything with it yet. It stays the same. Okay, and then, yeah, I think at this point we can see it actually is the exact same as what we thought it would be. And so I'm gonna simplify this quickly. It's gonna be 10x over 2 times the square root of 5x squared minus a 2. And then those 2's cancel there, and I have the 5x over square root of 5x squared minus 2. Okay, so we have one more example to go through, and I encourage you to take as many steps as you need to feel really comfortable and confident with these problems. I highly recommend starting with the u f of u idea, and then, hey, maybe give this a shot and see if you can find the structure on your own. All right, last one I'll do with you guys is this one right here. So I've got y equals 2 over this thing. Now, again, we've been talking about this. Anything that you can make a power rule becomes easier if it is a power rule. So I'm going to start by changing my square root in the denominator to a negative 1/2 power in the numerator. So this will look like 2 times 1 minus 3x to the negative 1/2 power. There she is. Okay, so now I'm going to start looking at inner structure and outer structure. And right now there might be some of you who are like, there's a 2. What is this 2 on the outside? Well, friends, it just becomes part of the outer structure. Check it out. Inner, which is u, is 1 minus 3x. F of u is just 2. U to the negative 1/2 power. So those coefficients are very well behaved. They stay on the outside over here and become part of that outer structure. All right, derivative of the inner. I'm just going to call it u prime. Save myself a minute or 10 seconds, whatever. Comes negative 3. My f prime of u. Let's bring that 1/2 down in front. And it gets multiplied to the 2. So 1/2 of 2 is just 1, and it's negative because that's a negative 1/2. Drop that thing. This is like negative 1 over 2 minus 2 over 2. So remember that conversation, how 1 is really anything you want it to be? I want common denominators, so 2 over 2 is my actual 1. And then that gives me my negative 3/2. I like to do that in my head and make my work a little quicker. Okay, so now I'm looking at y prime. Y prime is going to be f prime u times u prime. And here's how it looks. So negative u to the negative 3/2 power times u prime, which is negative 3. And when I start simplifying, I've got the 2 negatives that cancel, so it's 3. And I'm going to back substitute what u was, so 1 minus 3x to the negative 3/2 power. And at this point, this is a pretty acceptable way to write your answer, but I'm going to push you guys because I feel like not everyone's comfortable yet with how to make this into a square root, especially when there's that 3 on top. So first things first, that negative drops the whole thing down to the denominator. This 3 out in front will stay on top though. It doesn't have a negative exponent, so it's got to stay in the numerator. So now we've got it in the denominator. And if you recall, the number that's on the bottom, the 2 on the bottom, tells you the index of your roots. This is a square root. The number on top here, that 3, is saying you're raising that whole thing to like a third power. So this is probably how I would write my answer. Square root of 1 minus 3x being cubed. All right, so there are example problems from the textbook, and these should hopefully be enough to kind of assist you on your way through the homework problems. If you need any extra help, like make sure to be emailing me or asking questions in class so we can go over those things, and watch the other videos that I've posted in that page as well from other people explaining chain rule. Their words can be really meaningful if this one's not quite making sense.